This is part 2 of factoring quadratics. This is going to focus on what's called the AC method of factoring trinomials when that A value is greater than 1 and it's not a perfect square trinomial. So here are the directions in how we follow the AC method. Certainly it's not the way you have to do your factoring. If you learned another way that you like better, do the trial and error or the box method, certainly you can do that. In the AC method, the first thing you want to do is multiply your first term and your last term's coefficient, the A and the C. And this is what they call a magic number. We're going to take that number and factor it into pairs. Once we do that, then we're going to follow the chart. If C is positive and B is positive, both our factors will be positive. If C is positive and B is negative, both factors will be negative. And then when C is negative and B is positive, the bigger factor will be positive. When C is negative and B is negative, the bigger factor will be negative. Then we're going to add those plus and minus signs to that magic number factor pairs and see which pair adds up to our B. And then we replace B with the factor pairs. And I'm going to show you how to do that. We do factor by grouping, and then we write our two factors. So I know that probably sounded like a lot and didn't make much sense. So let's look at an example. And this will be an easy example because both terms, the second and third term, are both positive. So first we have A is 5, B is 19, C is 12. So you multiply A and C together. And then we come up with factors of this product. So there are a lot here, so I'm just going to do a few of them. And since C is positive and B is positive, I know both of these have to be positive. So I'm just going to do like 2 and 30, 3 and 20, 4 and 15. Then just like before, we're going to add these together. And I'm looking for the pair that add up to my B. Then I write this is a combination for the B. So I have 4n and 15n. But I want to make sure that I put them in the order so that they will have a GCF with the first and last term. So I'm going to write them as 5n squared plus 15n, because I know 15 and 5 have a common factor, plus 4n plus now 12. So I replaced the 15n plus 4n. I put that in place of the 19n. Now I can group these together. Factor out a 5n in the first, and factor out a 4. Oops, it's too early. Factor out a 4, and I did that again here. I don't know what I'm doing. And you're probably saying the same thing. You don't know what you're doing either. So I factored out a 5n in the first, and I get n plus 3. I factor out a 4 in the second grouping, and I get n plus 3. Then I take the 5n plus 4 And if you take notice, there's a common factor of n plus 3. And that is my answer. And maybe you don't like that method. That's fine. You don't have to do it that way. Whichever works for you. Okay, let's try another one. A is 3. B is -8. C is 4. Multiply A and C together. Okay. I take notice that B is negative. Excuse me, and C is positive. So when C is positive and B is negative, both terms are going to be negative. So I'm looking for factors of 12, both negative, that add up to -8. So if I do -3, -4, -2, -6, this is -7, this is -8. So there's my two factors that I want. So it's going to be -2n minus 6n is what's going to go in place of -8n. But I want to make sure I write them in an order that I have a GCF. So I want the 6n first because that has a GCF with 3. Now I can group. I factor out a 3n here. Let me make sure I do this right. But I take notice, I'm not going to get an n minus 2 unless, because this middle term is a minus, I need to factor out a -2. And then I have the same. The goal is to make sure that those two factors are exactly the same. Then we get 3n minus 2 and minus 2. Okay, I have two more here I'm going to do. And maybe you want to try them on your own and first, and then check with the video to see if you're right before you venture in, or maybe you just want to go right now to Khan Academy. Okay, so factors of 15. If you follow the flow chart, they don't pay attention to that sign, which is fine. I think sometimes it's easier just to pay attention to the sign, because then that way you're always adding these two together. -2, so it's 3. And minus 5n is what I'm going to replace. And I'll just slide that up so you can see that it should be 3p squared. And I want the -3m with the, oh, I'm doing it again. These aren't n's, they're p's this time. Minus 5p minus 5. So I group those two, factor out of 3p. And once again, I need a p minus 1. So in this one, if I factor out a negative 5. Oh, this should have been a plus. Factor out a negative 5, I need a p plus 1. Me and my signs. I think I was looking at the minus 2 up there and wrote minus 3 instead. Okay, and the last one. So plus minus, so I need one of each sign. So I'm going to use, I'm going to make sure I get the right variable this time. These are n's again. So I'm going to use minus 3n plus 6n. But I need to write the 6n with the 2n squared. Factor out a 2n. And again, I need a plus, and it's a minus on the last term, so I'm going to factor out a negative 3. And again, maybe you were watching this and you were saying, no way, I hate this. Trial and error is certainly a way you can do that. You have to look at the factors of the first term and the factors of the last term. And of course, you can watch the Khan Academy videos and see if they use a different method that might be something that you like better than this. AC method of factoring when A is greater than 1.